Good day and welcome to another physics lesson. Today we'll be looking at resultant forces with a view to looking at the parallelogram law of vectors. The parallelogram law of vectors. We will, by the end of this lesson, be able to define resultant vector, state the parallelogram law of vectors, and then calculate the magnitude and direction of resultant vectors using the parallelogram law. So, the resultant vector is defined as a single vector that can be used to replace a system of vectors and which will have the same effect in magnitude and direction as that system of vectors. Do not forget that vectors are essentially quantities that have both magnitude and direction. So a resultant vector is a vector that we can use to replace a system of vectors. So when you have maybe 2, 3, 4, 5 vectors acting on an object and they all create an effect on that object, then if you want to use just one vector to replace all of these other vectors, then that vector you have used to replace the other vectors is what is called the resultant vectors. So when two vectors act at acute angles means that they act at angles that is less than 90 degrees to each other. The resultant of the vectors is found by using the parallelogram law of vectors. When we dealt with perpendicular vectors, we found the resultant using the Pythagoras theorem. But now, because the vectors here are not at perpendicular angles to each other, rather they are at acute angles, then we use the parallelogram law of vectors. What then is the parallelogram law of vectors? This states that if two vectors are represented in magnitude and direction by the adjacent sides of a parallelogram, then the diagonal of the parallelogram drawn from the point of intersection of the vectors represents the resultant vector in magnitude and direction. So if you look at the diagram, you have first F1 and F2. They are at acute angles to each other. If you look at that diagram, they are essentially two adjacent sides of a parallelogram. Then the diagonal line, which is the green line in between, is the resultant. So if you are able to calculate that resultant, then we have essentially got the resultant of forces F1 and F2. Let's look at a solved example. Here we are asked to find the resultant of two vectors 3 Newton and 4 Newton at 45 degrees to each other. So we have two vectors 3 Newton and 4 Newton. The horizontal vector BA is 4 Newton. 3 Newton is a diagonal vector. That's the one represented by side BC. But since parallelograms have equal opposite sides, side BC and side AD are opposite to each other. So the same 3 Newtons is also at side AD. So AD is 3 Newtons. BA is 4 Newtons. Those are the two vectors. Now, once we find the resultant is that diagonal line in between, that black line. Now, in this diagram, you can see that I have completed the parallelogram. I drew the complete parallelogram. I introduced the two sides that we are missing. And each side has the same value to the side opposite it. That is why, even though in the question, the side we are given as 3 Newton is BC, but AD is opposite BC. So the same value that we have at BC will also be at AD. Now, the diagonal, as I said, is the resultant vector. Now, you will recall that the total angle in a parallelogram is 360 degrees. You will also recall that the opposite angles, two opposite angles in a parallelogram are equal. Opposite angles in a parallelogram are equal. So, since the angle between CB and BA, according to the equation, is 45 degrees, that means that angle B is 45 degrees. Angle D will also be 45 degrees because that's the opposite angle. Now, if we have B as 45, D as 45, that is 45 plus 45 gives us 90 degrees. Now, if we subtract that from 360 degrees, we will have what the remaining angles for C and A will be equal to. And that will give us 270 degrees. So A and C have 270 degrees in between them. But since A and C are also opposite angles to each other, then their values must be equal. So to find A, we just divide the 270 by 2. So both A and C are 135 degrees each. Now to solve for that resultant, you can see that we have a triangle there that is more of a scaling triangle. Now the resultant side in this case is got using a rule called the cosine rule. The cosine rule. The cosine rule is a rule that has 3 formulas, but we only need one formula to work. But I've written the 3 formulas here. A squared equals B squared plus C squared minus 2BC cos capital A. Also, B squared equals A squared plus C squared minus 2AC cos capital B. Then C squared equals A squared plus B squared minus 2AB cos capital C. Essentially, if you look at the equations, you will see that one side that we are looking for, the square of that side, is equal to the square, the addition of the square of the 2 other sides of the triangle, minus 2 times the product of these 2 other sides that we know, cos the angle opposite the side we are looking for. Note that in our triangle notation, we use capital letters to indicate the angles in a triangle, but we use small letters to represent the sides. The sides. Capital letters or uppercase letters are for the angles. That's the points where the sides meet. And then the small letters or the lowercase letters are for the sides. Now, the capital letter and the small letter of the same alphabet must be opposite each other. That means that if you have an angle capital A, then the side opposite that angle will bear the letter small a. If you have an angle capital B, then the side opposite that angle capital B will bear the letter small b. That is how notation is done for triangles. So it is on that knowledge that these formulas are developed. So you have to do the correct notation for your triangles to be able to apply this formula correctly. Going back to the question now, we are looking for the side small a. Since we already know small b and small c, that's 3 Newton and 4 Newton respectively. So the a that we are looking for, we use a squared equals 3 squared plus 4 squared minus 2 times 3 times 4 cos 135. 135 is the angle as capital A, which we got earlier. If you do that correctly, not forgetting that 2 times 3 times 4 cos 135 are all on the after the minus side of the equation. They are all multiplications. So the operator there is multiplication. You must multiply them first. Now whatever you do get, you now subtract it from 3 squared and 4 squared. But for me, my answer gave me minus 16.97. Now, if you multiply minus 16.97 by the minus we already have in the equation, you get plus. That's why we have 25 plus 16.97. Now, don't forget that we are not looking for a squared. We are looking for a. We are looking for the resultant. That is the square root of a squared. That's how we got 6.48 newtons. Now, to find the direction, we use a principle called sign rule or Lamai's theorem. Sign rule also works on the notation of triangles that I explained earlier. Capital letters for the angles, small letters for the sides opposite the angles. So, small a over sine capital A equals small b over sine capital B equals small c over sine capital C. That is the Lamai's theorem or sign rule as it is called. Now, the direction you are looking for is the direction theta. That's the angle between the diagonal, which is the resultant vector that we have found, and the horizontal. That is the angle we are looking for. That is the direction. Doing that, we can have the resultant that we got divided by the sine of the angle opposite it. That's sine 135. That's the angle opposite it. You can go back to that diagram again. Equals to 3. That is the vertical, the slanting force or slanting vector divided by sine b. Sine b is now the angle between the resultant vector and the horizontal, and that's the angle opposite the 3 Newton vector. So sine b will then give us 0.3274. We are looking for b, we are looking for the angle, so we must do the sine inverse, and that gives us 19.11 degrees. So the resultant of the two vectors is 6.48 newtons, direction 19.11 degree. Or if you want to use your 4 cardinal point bearing, you say north 70.89 degrees east. Using the same procedure that we had above, we can find the resultant of these two vectors also. 7 Newton and 5 Newton. Angle between them is 50 degrees. As usual, you should complete a parallelogram. If you complete a parallelogram, you'll find that the opposite sides will also have the same value. So 5 Newton is also the value of the side opposite the initial 5 Newton that you were given. And then 7 Newton is also the value of the opposite side. Now, we now have a triangle with two sides, 5 Newton and 7 Newton, and then a resultant that we are looking for. Using the same cosine rule, our a squared, that's the one we are looking for, equals to 5 squared plus 7 squared. That's the square of the two angles two sides that we already have, minus 2 times the two sides that we have, cos the angle opposite the side that we are looking for. If you have done your work well, you will see that angle A will have given you 130 degrees. Using the same principle as I explained above, the angle between 5 Newton and 7 Newton is 50 degrees. That means the opposite angle is also 50 degrees. That's 100 degrees. Now subtract 100 from 360, you have 260. Now the two remaining angles will both have a combination of 260. That means each of them will have half of 260. That's how we got 130 degrees. Now solving that correctly, you will find your resultant to be 10.91 newtons. You may take your time to solve this by yourself. And then to find the direction also, using the same sign rule I talked about, we have the resultant that we got, 10.91, divided by sine of the angle opposite it, that's 130 degrees, sine 130 degrees, equals 7 over sine b. Don't forget that the direction is the angle between the resultant and the horizontal vector. Angle between the resultant and the horizontal vector. Doing that correctly, that angle gives us 29.44 degrees, or if you like, north 60.56 degrees west. And that is where we end the class today. I hope that you have been able to learn how to apply the principle of parallelogram of vectors in solving for the resultant of vectors that are at acute angles to each other. Once again, do not forget to subscribe to this YouTube page if you haven't. And also, do not forget to drop comments. If you do have a comment or you have a question, please do not hesitate to drop it in the chat box and I will get back to you. Hope to see you in another lesson sometime soon.